Hello everyone, welcome back to our subject Modern Operating System and Computer Network. Myself Dr. Madhivanandarai, currently working as an assistant professor to the Department of School of Computer Science and Artificial Intelligence at SR University Varangal. Today we will discuss about this network layer and network layer design issues. So generally the role of network layer serves the backbone of internet communications. So from one region to another or worldwide. So it responsible for routing the packets from source to destination across multiple interconnected networks at worldwide. So wherever the network is available, we will interconnect the networks and share the data with effectively by packeting the data. So for example here, as a sender, he can send the data to the Alice also. Bob will send the data to Alice by interconnecting the networks. So in between that time, the network should be the data should be stored into the node or router, then distribute to the receiver side. So coming to the today discussion, we will explore the five or six chapters, six, six things like store and forward packet switching, and next is search to upper layers and connectionless versus connection, then routing and forwarding, then challenges. What are the challenges in the network layer, and summary of the today discussion. So coming to the introduction of network layer, what is the role? So actually, it mounted in the OSI model, operating system interconnection, as a third place of which located as a network layer in the OSI model. Among the seven, it's the third place. So the layer in the OSI models like routers routes the packets from source to destination across the networks. So which means that the network layer will help to send the packet from one source to destination point across the network. So it provides a logical addressing. So how should we send the file from particular person sender to receiver based on this IP address? So IP address should be provided by network layer. So here, as I mentioned, like it provides a logical addressing, which means IP addresses through the network layer, and it handles path determinations across the multiple hops. Then operates on routers, not switcher or hub. So which means it operates on routers, not a switch or hubs, and abstract the physical networks from upper layers. So coming to the key factors like the network layer is responsible for the end-to-end delivery across the homogeneous network. The internet is built on these principles, based on this. So across the network or network conditions, we can transferring the data based on this IP address. So coming to the store and forward packet switchings. So what is the role of for store and forward packeting switches means? So how packets travel the networks? Like this is a source, a sender, or host. Here a host A2 the file or frame should be reached or packet should be reached to the host B, which means the destination. Like initially, messages are broken into smalls, fixed size packets. We need to split the packet size at fixed size at fixed size. Then it should be stored into the routers. So each packet stored temporarily at each routers. Then the routers read the headers, makes the forward decisions. So once a packet should be stored into the each routers, then the headers, the routers read the headers, makes a forward decisions to the destination sent to the destinations. So the packet forwarded to next hop on the path. So next hop is nothing but to find the nearest node of nearest node to send the file at effectively. It should not take more time to reach the destination. Who is the nearest node? It should be stored, and from that node it should be forward to the destination point. So that's why we are saying next stop on the path. Then packets may arrive out of order and reassembled at the destination point or destination. Then it enables a statistical multiplexing of network's resources. So why store and forwards? So while storing, we can error checking before forwarding and prevent the corrupted data propagations. So it's simply like in the previous lecture, we will discuss about this simplex protocols. In that protocols, like we will get acknowledgement from the sender to receiver, sorry, receiver to sender. Then we go for the further transferring the frames. So same like here, like why we need to store and forward. So the role of stored like error checking before forwarding, preventing the corrupted data's propagations. Then allows routers to handle the traffic burst through the queuing. So which means allowing routers to handle the traffics. So like traffic man. So traffic man role should be like regulate the vehicles moving at properly without any traffic occur. So here also like while storing and forwarding, the it allows routers to handle the traffic, which means that data should be moves continuously without any stopping, with it by handling routers and burst through the queuings. So the next is like it enables a priority based forwarding methods. So who want to go early based on the priority, it will enables to forwarding to the destination point, reach the destination. Then supports homogeneous link speed across the pods. So coming to the compare, like a circuit switching reserves a dedicated path for whole calls, while like a packet switching share the bandwidth dynamically, more efficient and more elastic. Lens resilience or more resilience. The next we will discuss about the service provided to the transport layers. So the service, what are the service should be provided or we get from the transport layer, like the first goal like hardware independence. The transport layer should not needed to know what type of physical network is under underneath it, like Ethernet, Wi-Fi, fiber, etc. like that. The network layers are abstract. The next goal is uniform service interface. Like a transport layer sees the same API regardless of whether IP and ATM or frame relay is running both. It enables like portability and interoperabilities. The next is design principles for network layer services like simplex design principles in the network layer like simplicity. So keep internal simplicity, simple format or simple, and complexity at the edge cases or edges. Then scalability, like it must work for millions of nodes at worldwide, and reliability. So deliver the packets even when the link is failed as well. And coming to the efficiency, maximum utilization of network bandwidth can be transferred effectively. Coming to the connectionless versus connection oriented service. So in the first lecture, we discussed about this connection oriented and non-connection wireless like that. So here is a small discussion based on that one. So coming to the connectionless datagram models, no setup phases before sending. So no setup phases before sending the file or before sending the packets from sender to receivers. And each packet carries a full destination addresses. So for example, if I need to share the packets of a size should be 10 MB or 20 MB like that, each packet should be the same IP address to reach the destination point. It does not change any different IP address. And packets may take different routes because based on this route, like who is the nearest hub or nearest nodes, it will take, and each frames take a different or respective hub or routes to reach the same destination point. That's why we called as a packets may take a different routes to reach the destination points. So then packets can arrive out of the orders. So which means based on the priority, some packets maybe have some priority, then it will go for faster than the next or non-sequence order of frames. So no state maintained in routers. So here no state maintained in routers, which means no order way. And internet IP uses these models. So while coming to the connectionless method, definitely we are using the internet IP uses these models for the transferring of frames. And this is a very simplest and robust and fault tolerance methods. Then connection oriented method or virtual circuit methods setup we need to demonstrate like call establishment phase first. We need to set up connection oriented and net communications, then virtual circuit ID in packets, not fully addresses, then all packets flow the same path. There is no different kind of path to reach the destination point. It should be go for only one flow methods in the wire based connection oriented methods. Then state stable maintained at each routers, and ATM, frame, relay, MPLs use these methods. then predictable performance QoS supports. Coming to the keys, like the internet choice, internet choose the connection IP address because it is a simpler and more resilient method. And complex ordering reliability was pushed to a transport layer. Coming to the routing versus forwarding. So the purpose of routing is the process of routing descending, like the process of descending which path packet should be take, like running routings. For example, it runs routing algorithm for use for the OSPF or BGP methods, then build and maintain the routing tables, then consider for the topology or cost and policy methods, then execute no longer timescale methods, very faster can execute at a second wise, and analogs to planning your route on map. Then forwarding, like the action of moving a packets from input to output port, like it looks up destination in forward tables and execute pre-packets must be very faster method, and it done in hardware like AS, ICS in modern routers methods and non-second timescale prevention operation methods. Sorry, nanoseconds timescale operation methods when compared to the routing methods, and it analogs to analogs to physically driving tune by tune, turn or turn by turn. So the next chapter, we, as I said, in the core design challenges in network layer. What are the core design challenges while implementing while using network layers, like routings? So finding optimal path in dynamics. While transferring the data should be framed or byted different size, not a different size, splitted as a size. This size should be choose by destination to store the file frame to sender to receiver via choosing the optimal path to reach the fast manner by nearest hub. Who is our nearest hub? The file should be stored to the nearest hub, then evaluate the file, then forward to the receiver side. So that's why we are saying finding optimal path in dynamics. So there is a method to find the optimal path, like a Digixstar algorithm. So that algorithm will support to find the shortest way of route to reach the destination point of data storing method. Some other method also there. I will discuss in the upcoming lecture. So the next role of routing, like a large scale network environment where the topology constantly changes and the link conditions vary. Then addressing. So coming to the challenge in the challenges in network layer, the next is addressing. So uniquely identifying the devices both globally and locally, which maintain the hierarchical structure for efficient routing. So we need to identify device here, like in local as well as in worldwide as well, or globally also, while maintaining the hierarchical structure for efficient routing methods. We need to identify the device. Then fragmentation. Coming to the fragmentation, it handling the packets of different size across the networks, which varying maximum transmission unit. requirements. Then quality of service. So managing the managing delay, jitter, and packet losses ensure the reliable communications for different applications requirements. So quality service will support to the managing delay. In case of delay process, it should be managed for different application for requirements as well, based on the applications. The next one is a scalability. So it's supporting to billions of devices and exponentially growing traffic volumes without performing degradations. So the scalability supports of billions of devices and exponential growing traffic. So while transferring the files, maybe possible to making it traffic of data transmission, it should be uh, uh, while transferring a large volume of file without performance degradations. The next is performance, another chapter like a performance. So the upper layer protocols that uses a service of network layer expert to receive an ideal services. So in the upper layer protocols that uses a service of network layer expect to receive an ideal services. So we will for getting the ideal services or effective of data transmission, upper layer protocols that uses for service. So the performance of the network can be measured in terms of delay and throughput and packet losses. So for each work we need to evaluate by based on the performance. In this data transmission, how performance can be analyzed means by by measured by delay of data receiving method, data receiving sender to receiver, and throughput and packet losses. In case of packet losses, also we can say so performance losses and time delay also. So these are the categories. Congestion control is an uses issues that can improve the performance. Like in the delay methods, there is a four category of delay for the data transmissions. All the uses of expert and interness response for from network, but packets from its sources to its destination encounters delays. The delay in network can be divided into four categories like transmission delay, propagation delay, and process delay, then queuing delay. So these four category of delay can be appeared while transmitting data. So one is the first we will discuss about this transmission delay. A source, host, or router cannot send a packet instantly for file should not send instantly that we call transmission delay. A sender need to put the bits in a packet on the line one by one. So in the delays we can calculate or evaluate it by packet length over the transmission rate. Then propagation delays. So coming to the propagation delay is the time it taken for the bit to travel from point one point to another point. Like how much time to take to reach the bytes from sender to receiver or point A to point B in the transmission media. So the the propagation delay for packet switched networks depends on the propagation delay of each network LAN or WAN. So how should be like the propagation delay for packet switched network depends on the propagation delay of each network, like a different network we are using WAN and LAN. So based on the LAN and WAN, we can propagate the delays. Delay can be observed. It should be varied, which means so the propagation delay depends on the propagation speed of media, which is 3 times 10 over the 8 milliseconds. So in vacuum and normally much less in wide medium. In the wired medium, like in vacuum and normally much lesser in the wired medium. So it also depends on the distance of link. So based on this distance, if it is a shortest distance of uh, transmission, we will enhance the faster execution of data transmissions, as well as the vacuum and normal much lesser in the wired medium. So in other words, propagation delay is called the ratio of distance over the propagation speed. So the speed, as we mentioned here, 3 times of 10 8 power 8 milliseconds. Coming to the next delay, like a processing delay. So the processing delay is a time required for router or destination host to receive packets from its input port. So it's a time required for router or destination host to receive a packet from its input port. How much time to take from input port? So remove the headers, perform an error detection process, and deliver the packets to output port in case of routers, or deliver the packets to upper layer protocols in case of a destination host. So the process delay may be differ for each packets because of some packet may be reach very faster based on the priority or size, or based on this choosing the nearest hub, or which means the route nearest router or shortest routers to reach the destination. But normally in is calculated based on the average of delay process, the time required to the process a packet in a router or destination host. So the next is queuing delays. So queuing delays can normally happen in routers. How? A queuing delay for packet in router is measured as a packet wait in a packet wait in the input queue and output queue of routers. So input packet wait in the time packet wait in the input queue and output queue of a router. So which will called as the ratio, like a time packets wait input and output queue in the router. So some plans may be needed to wait to get a landing band, like input delay. Some plans may need to wait to get depends on the band. So it should be changed. So delay types in the last one, total delay. So assuming equal delay for sender, router, and receiver, that total delay sources to destination delay. Like sender also we can consider, router side also we need to consider, and receiver also we need to consider. The total delay is called as a we need source to destination point. We called as a total delay. So we need to add it. Like a packet n counts can be calculated if we know the number of routers like a n in the whole path. Like a total delay, we will calculate it by n plus 1, which means the number of routers, and time delay plus router delays and propagation delay and process delay time propagation and process delay plus times of delay queue. All the for the previous all the transmission and propagation and process and queue sums we calculated for the total delay. So coming to the outcomes from this lecture discussion, we will learn we learned we will understand the fundamentals design goal of network layers and understand the role of a network layer in routing, forwarding and congestion control. Then differentiate between the transmission delay and the propagation delay, then process delay and queuing delay methods. So these are the discussion was learned from this lecture. So in the next lecture we will discuss about this in the protocol layers. What are the protocols are used in the network layers? We will discuss. Stay on the channel. We will discuss on the next lecture. Thank you very much.